Now that we've extracted the body text of an email from a single email, we need to do this for all our emails. And for that, we need to create a function. The kind of function that we're going to create in this lesson is a special type of function in Python called a generator function. In other words, we will create a function that reads all the files in a folder. Now, the functions that we've encountered so far run once and they return a value. If you recall, a standard Python function just has that return keyword and then it spits out a value following whatever comes after that keyword, and that's it. And what this means is that a function needs to return all the results at once. It needs to return all the results at the same time. Now, if we wrote a function that read all the emails and extracted the body text from all the 5,000 emails all at once, then we would have to return 5,000 email bodies all at the same time as well. Now, if this sounds like a lot of work, then you're absolutely right. And we don't have to write our Python code to do it this way. There is an alternative. And this is where generator functions come into play. In our Python notebook, let's add a markdown cell that reads generator functions. And in the cell below, we're going to go over this advanced functional pattern that you're going to encounter every time you want to spit out a series of values. We're going to be combining two very powerful programming tools. The first one is loops, and the second one is this generator function. So before we parse 5,000 emails, let's go through a practice generator function. It starts out the same way as every other function with the definition, def keyword. Then I'll give it a name, generate underscore squares. And then I'll give it maybe a capital N as a single parameter. And then inside this function, I'll write a loop for my underscore number in range, this is going to be up to n, yield my underscore number to the power of 2 times 2. This here is my generator function. It will take in a single value, n, and it will run the loop n times. Now, one difference that you'll notice is that we don't have a return keyword. Instead, we've got this other keyword here, yield. Let's call this generator function to see how it behaves. Then we'll talk a little bit more about the syntax. Having pressed Shift-Enter on the cell, you might think that all we have to do is call the function by using its name, like so. Generate squares 3, say, and press Shift-Enter. But in this case, the output looks a bit unexpected. Instead of squaring, say, the number 3, what we get is a generator object. So how do we call this function in a more useful way? One thing we can do is wrap this whole thing in a loop, and then you'll also see how this generator function actually works. So if I say for I in generate squares, semicolon, print I, and then the comma, and then say at the end, put a little arrow in between the results. And let's hit Shift-Enter now. So this is interesting, right? We get 0, 1, 4, and then each number is separated by a little arrow here. What's going on? Our loop will run 3 times because n is equal to 3. But what we're doing here is we're feeding in the values into our generator function one at a time. The first value that we feed in is the value 0, and 0 squared is equal to 0. Then we feed in the value 1. 1 squared is equal to, well, 1. Then we feed in the value 2. 2 squared is equal to 4. And the amazing thing here is that this function, using the yield keyword, remembers where it left off. So let's change our argument here to the number 5 and see how this goes. Now our sequence looks like this. 0, 1, 4, 9, 16. In contrast to the return keyword for a normal function, where the function basically exits with a value and we're done for good, with the yield keyword, it's sort of exiting the function, but it remembers the state where we had exited from. So in this case, we're iterating through our loop, and it remembers the previous value that it was at. and we're starting from the point where we had yielded from. But why is this interesting? Why does this matter? At first glance, it looks like we could achieve the very, very same thing with a normal function that uses the return keyword instead of having these loops and iterating through a generator function. Why would we do this? Well, here's the thing. With a generator function, we don't have to do all the upfront work. So in our case, we've got 5,000 emails that we have to parse. With a large data set like that, or an incredibly long list, it takes an incredible amount of computation to even produce a single value, let alone thousands of them at the same time. So what we're going to do now is we're going to apply this generator function to loop over and iterate over all the files in our directory that holds on to the spam emails. And then we're basically going to pass one email at a time. That's how we're going to use this generator function. Let me add another markdown cell here that reads email body extraction. And what we'll do here is we'll define a generator function that walks over all the file names in a particular folder. This is a function from the operating system. Here's how we're going to use it. So we'll wrap the whole thing in a function, yeah? def email underscore body underscore generator. And this is going to take a single parameter, namely the relative path to one of our folders, the spam folder or the folder with the legitimate emails. Now what we'll do is we'll write a loop. We're going to say for root, comma, directory names, dir names, comma, file names, in walk, parentheses, path. This walk function is where our operating system comes in. The walk function generates the file names in a directory by walking the tree from the top to the bottom, and it yields, that's right, it doesn't return, it yields a tuple, so 3 things, consisting of the directory path, which is this first one here, the directory names, which is the second one here, and the file names, which is this third one here. The directory path is obviously the path to our spam folder in this case. The directory names are the subdirectories, which we're actually not going to use. And the file names is the bit that we're actually interested in. This is going to be a list of names of all the files in our directory. In other words, if we point this function to easy underscore ham underscore 1, then we're going to get all these file names right here. We're going to get all the file names in this easy underscore ham directory. This is what we're after. Now, the walk function is not inbuilt. It belongs to the OS library. So let's import it at the very top of our notebook. Scrolling up, we're going to say from OS import walk. And while we're up here, we're also going to import something else that we're going to be using in this function, namely the join method. So from os.path import join. Now let me hit Shift Enter and scroll back down. Let me add a semicolon and let's write the inner part of this loop. The inner part of this loop is going to make use of all the file names that we're retrieving using the walk function. So what we want to do with a single file is actually very, very similar to this bit of code that we've written earlier. But since this function is going to return all the files to us, we're going to have to tackle each file one by one. But let me copy this code nonetheless, and then down here, we're going to add another loop. Namely, we'll say for file underscore name in file names, semicolon, and then let's paste in this code. I'm going to select this bit here and just hit tab on my keyboard to indent it and make sure it's in the body of my inner loop. And then I'm going to have to make another change. we're not going to be targeting our example file. We need to be targeting a particular file in this list of file names. How do we get that? Well, we'll say the file path of a particular file is going to be equal to joining the root, which we're getting here from our outer loop, to a particular file name that we're iterating over in our inner loop. So we'll say combine the path for the root directory with a file name that we're iterating over in our loop. And then in our open function, we can replace example_file with file path. Everything here will remain the same. The only thing that's going to change is that we're not going to be printing out the email body. We want this function to spit out two pieces of information. One is the file name, and the other one is the email body. And this is where we're going to use that yield keyword once again. So we'll say yield file_name, comma, email_body. Now I know this bit of code looks very, very involved, but we've broken it down quite a bit in the previous lessons already. So for example, we know that this bit of code extracts an email body from a particular file, and we know that using the yield keyword, this function here will give us a result every time it loops over a particular file in our directory. So I'll spit out this file name, then I'll spit out this file name and this email body, then I'll spit out this file name and this email body, and so on. The only thing that's really new is this walk function from the OS library, which spits out a tuple, which we're using in our loop, and we're nesting a inner loop inside this one here to go over all the files one by one. Now that's half of the work done. If we look back up here, we've essentially done this bit. We now need to write the second piece of code that actually calls our generator function. We need to write a loop that repeatedly calls our generator function. Let's put the second piece of code inside a function as well. So I'm going to go down here and I'm going to call this function data frame from directory. So df_from_directory. And it's going to take two inputs. It's going to take a path and a classification. And by classification, I just mean whether this email folder is going to contain spam emails or legitimate emails. To create our data frame, we will start out with two empty lists. So I'll say rows is equal to a pair of empty square brackets, and row_names is also equal to a pair of empty square brackets. Our generator function is going to be called inside a loop. So we'll say for file_name, comma, email_body, which is what our generator function is returning, in email_body_generator, and then our generator function here needs one input, namely a path. And by the way, if you haven't pressed Shift Enter on this, it's a good idea to do so now. And once you've done that, all we need to do is supply a path to our generator function as an argument. And I'm just going to feed through the path that is being passed into this data frame from directory function to our generator function right here. Inside the loop, we're going to append our email bodies to our rows list. So I'll say rows.append, parentheses, curly braces, single quotes, message, colon, email_body, comma, single quotes, category, colon, classification. So what I've done here is I've created a Python dictionary using the values that our generator function spits out. Each time this loop runs, it's going to give us a file name and an email body, and we're storing this in a list where we're appending the email body one by one as it goes over the files. Next, we'll do something very similar for the row names. So row underscore names dot append parentheses file underscore name. Now, this data frame from directory function here is going to be a regular function. It's not going to yield anything. It's going to return a data frame. So pd for pandas dot data frame parentheses rows comma index is equal to row underscore names. And that's it. Except that we need to import pandas as pd at the top of our notebook, of course. So let's do that now. Import pandas as pd. Shift enter. Scroll down and hit shift enter on this as well. Now we've written quite a bit of code and we haven't tested it at all. So we're not even sure if all of this will work or if we've made an error. Let's try and call this data frame from directory function and see if it works. But before we do that, let's add all our paths to the top of our notebook under this constants heading. The paths that I'm interested in are the paths to easyham_1, the path to easyham_2, spam1, and spam2. So let's create 4 constants with these paths. The kind of path that we're going to be working with is going to be a relative path. The base classifier notebook is located under ML projects. So our path will have to go into spam data, 01 processing, spam assassin corpus, and then it'll have these folder names afterwards. So here we go. Spam_1_path is going to be equal to this first bit here, which I'm just going to copy and paste. Then we said it was spam_assassin_corpus. And then we said it was going to be spam_1. This is the relative path from our base classifier notebook to our spam_1 folder. Now remember, everything is case sensitive and you've got to use forward slashes between the folder names to avoid getting any errors. Let's tackle the other 4 relative paths now. So I'm just going to copy this, paste it 3 more times, and rename our constants here as well. So spam2 path, this one I'll call easy non-spam1 path, and this one I'll call easy_non-spam2 path. The folder that these ones are going to point to is going to be easy_ham2, easy_ham1, spam2, and spam1, of course. And that's it. If we hit shift enter on this and just make sure we haven't made any typos, we're good to go. Let's call our df from directory function and create a data frame of spam emails. So I'm going to call this data frame spam_emails, and I'm going to set it equal to df from directory. Note, I don't have to type all this out. I can just hit tab on my keyboard, parentheses, spam1 path, comma, and then the category for spam is going to be the number 1. Now, before I continue going, let's look at the head of this data frame to check out the first few rows. So spam_emails.head, parentheses, and shift enter. Voila. Here we can see the file names of the first 5 rows. We've got a category. Category is going to be 1 for spam and 0 for non-spam. And then we've got the messages, in other words, the bodies of all the emails, as a column in our data frame as well. Let's take a look at the shape of this data frame to see if we've got all our emails. Spam_emails.shape. Shift enter gives us 501 and 2. 2 for the number of columns, the category, and our email bodies, and 501 for the number of rows in other words, the number of messages in this folder.